Alrighty, we are back on the Tesla coil build. So if you remember this simplified diagram I did a while ago, we're going to be working on this area right up here. This is main power coming in. Now this section here, from the schematics, it's not technically a circuit board. These are just a bunch of components that they just have connected with 12 gauge wire. And it's basically just a few resistors, a couple of thermistors, and some fuses. And the finished board, this is what my finished board looks like. Now, for as simple as this is, it took me more time than I really want to admit designing it. This is probably my fourth version of this. Let's see, my first, typically when I design a board, I sketch it out on paper first, what I want. This is, actually that's my second version of it. This is my first version of it. You'll notice I have power and neutral coming in here. I have power going out there to the fans and the controller. And then over here I've got wires that would come off to capacitors and the rectifier. But I didn't like that because, I wanted, well, this is what I wanted, so power for a capacitor. So what happens is there'll be a capacitor that mounts across here and another capacitor that mounts across there. Those are these rather large capacitors here. So again, one will go here, connections here to here, and then one will go here, and then right there. And again, where's the, there we go. This is actually bigger than the capacitor they call for, both capacity and voltage-wise, but it'll fine. I checked with the engineers over at Eastern Voltage Research. They said this would work perfectly fine, no problem. So the way this is mounted, again, those two capacitors, they'll be side by side here, and I want that board right on top, so I could just bring these cables down and right to the capacitors. So I didn't want these wires that go to the rectifier in the same area. I wanted those to be here where the rectifier was going to sit down there. And so I redrew it to look like that. So now you got the rectifier wires coming here, capacitor wires coming here, but I'm thinking, I could simplify this if I just move all those over, and that'll kind of ease things a little bit. So I redid it, and well, actually you can see what I have here now. So again, these three wires go to the rectifier. Of course, the rectifier has 4 lugs, and on this design we're just not using one of the lugs, we're only using 3 of the 4. So if we just kind of go over the board, what's going on here, mains power will come in here. I'm still trying to decide how I want to make that connection, if I want to put some screw terminals there, or just solder the cord directly to the board. Still trying to decide what I want to do there. But mains power comes in, we'll have a 20 amp fuse, and then from here we go through the current limiting inrush thermistors here. Again, these 2 resistors, as you can see, will be in parallel, one across each capacitor. And optionally, I added, this is in the schematics, as an option, this relay and this resistor here. And when the relay is relaxed, which it is now with power off, that relay is relaxed, that resistor is in parallel across here. And what that does is it drops the capacitor voltage down much quicker. Now without this, those 2 resistors will drop the capacitor values, or drop the capacitors down in about 30 seconds. But with this resistor, it'll drop them down in about 5 seconds. At least, if I remember right, that's what I heard somewhere. I don't know. This was actually kind of an afterthought. Coming off here, we're going to have power and neutral going to the fans, cooling fans, and we'll have them coming out here for the controller. And I decided I didn't want long wires just hanging off of this, so I just routed those down to screw terminals here. And part of why I'm doing a lot of this is ease of disassembly. For example, the capacitors, I got these lugs here, and these are for 12 gauge wires, and I will just have those bolt on right there. I'll explain that mess in a minute. So those will just bolt on here, and then that'll be to a 12 gauge cable that then goes to the lug of the capacitor. And again, screw terminals for the fans and the controller. These I don't mind. We just have spade connectors that will plug in here, so that'll be easy to take apart. And I'll probably do something here, again, for ease of assembly and disassembly. Now, on the back side, yeah, that looks like a mess, but there's a reason for it. After I designed this all out, I found a thing online. It's a printed circuit board trace width calculator. You put in values such as copper thickness and the current that's going to go through it. And the fuse here is a 20 amp fuse. Now I know the circuit's not designed to pull 20 amps. You're not going to put a 20 amp fuse in a circuit that's designed to pull 20 amps. That would just not be good. So 20 amp fuse, this thing's probably going to normally pull 15-ish, give or take. But if there's a problem, I want the fuse to blow before my copper foil blows. So at 1 ounce copper and 20 amps, those should have been about, I forget exactly, 20 millimeters wide, and those are not 20 millimeters wide. But even if you just make it a little bit thicker, that cuts that width way down. So I was concerned about the trace here and here, so I added some copper braiding and flooded all of that with solder. Even these here, these down here are low current. This whole area down here, this is only going to see an amp at the most. So the traces would have been fine, but I went ahead and tinned them with solder. For one thing, just to keep the copper from corroding. Yeah, I know I could put the green mask on it like I did the others, and I might still do that maybe. I don't know. Probably not. Because the solder will keep the copper from oxidizing. Where the leads go here, I just took one of those lugs, flattened it out, and soldered it directly to the board. That gives me a nice solid connection for bolting those wires to. And anywhere I could, like where that thermistor went through, I just folded the leg all the way over and just flooded that with solder. So current flow will be perfectly fine. This is plenty wide enough. Didn't really need to solder on that, but it's wide enough there. So not the prettiest looking thing, but it'll work. And won't really be seen, except for you and me. Anything else about this? Yeah, I think that's pretty much it as far as this goes. Let me get some stuff set up here and we will test it. Okay, so I have a fan connected to here. I have an amp meter connected to some mains wires coming in. This is just temporary, and no, that is not the same cable. I'm not that stupid. Those are two separate cables, right? Two separate cables. Those are just there for clamping force for the mains on the back of the circuit board, because I don't want to solder anything to it yet, because I don't know exactly what I'm going to do there yet, and I don't want to do anything. Well, I guess soldering is not permanent. I could unsolder it, but it's just temporary. I have a meter here across those two resistors, and right now we're looking at 1 kilo ohm, 0.989 kilo ohm, and that is because that relay is relaxed, putting that resistor in parallel across these. These are both 20K each, so when I plug it in, you'll hear a click of the relay, which will remove that from the system. Putting those two in place, and we'll be looking at hopefully 40 kilo ohms right here, and we'll see what the total current draw is of the circuit. And that's going to be the current draw of the fan and the relay, and that's pretty much it. Power is not really going anywhere else. And so we'll plug it in, listen for the click of the relay. You can hear the fan running. So fan over here blowing stuff on the other side of the shop. And we're looking at 39.9 kilo ohms. That's close enough to 40 for me. And 0.37 amps. And which the fuse to the fan it's a 1 amp fuse. And again, that's the amperage for the fan and that relay. So no smoke. Of course, I didn't really expect much because there's not really that much here. But, you know, just to make sure the relay works, the resistors work, they're doing what they're supposed to do. It's good. And this is actually kind of a momentous occasion because this is technically the first thing on this build I've actually tested. So that's kind of cool. Let me break this down and we'll look at something else. All right, how's this for something else? This is the primary coil, and I can't even. That's the wrong way. Let me try. That's a little better, but can't even get it all in the camera. Now the schematics called for this base plate here. They called for 1/2-inch acrylic. I did not have 1/2-inch acrylic, but I did have 1/4-inch acrylic. So this is actually 2 squares cut out and bolted together. And you can see bolt holes along here. Probably by next video, I will start working on the frame or the structure that's going to hold all of this stuff. So I got holes along here for bolts to go through, probably way more than I need, but that might give it kind of an industrial type of a look, which I think would be fine. These pieces here that hold the coils in place are 3D printed. Again, the schematics call for, again, 1/2-inch acrylic. I didn't quite fancy hand cutting all those out of acrylic, so I 3D printed them instead. Now, I used the dimensions from the schematics and I drafted them all out myself, but they are available online to be downloaded, and that probably would have been a lot easier. But yeah, oh well, no big deal. And on the bottom of these, there's a threaded insert that gets heated with a soldering iron and pushed in from the bottom, and then screws through the plexiglass and up, holding all of those in. This outer bar here is just 3/8 copper plumbing, and that's your strike rail. That has to be open at this end. If those are too close, it'll kind of create a short or something like that. So that has to be open, and it shows that in the schematics. I still need to add a hole in here somewhere to bring the feed wire into here, and then 5 out, there will be a tap wire. So I'm going to have to put another hole in here for the tap wire to come in and clip on. And they give you about 7 or 8 rows. So 3, 4, 7, 8. So they give you 8 wraps here, but we're tapping off at the 5th wrap. And that's where they specify to put it. You could experiment and put it where you want, but they say this works better at the 5th wrap, so that's what I'll do. But this actually came out pretty cool. I'm really liking this. Of course, the secondary coil will mount from the hole right there in the middle between that. So I'm really kind of getting to the point to where I need to start getting a better camera mount. And come on. My camera mount has been a pain in my side for a while, so that might be another project. But I'm really getting to a point where I need to start building some structure to hold all of the stuff I've been making. So I'm going to wrap this video up for here. So as always, until next time, thanks for watching.